This is section 6.1, slope fields. So hopefully you watched the video on introduction to slope fields, so you have a general idea of what they are and what they represent. So in this video I'm just going to create a couple of slope fields. So here are the kind of guidelines I've come up with for creating a slope field. So the main thing is to remember that the derivative represents the slope of a function at a point. So what we're going to do is we're going to draw small little line segments at each point that's based on the value of the derivative. So we're going to use the derivative to tell us what the slope is and make small line segments based on that value. So first example is going to be the derivative is x plus 1. And what I have over here is just a grid. I made it 4 units in each direction. Okay. So the easiest point to begin with is going to be the origin. So I'm going to start over here in the middle. And if I plug in x equal to 0 into the slope, to the derivative, sorry, the slope, well, 0 plus 1 is going to be 1. So at this point, it's going to have a slope of 1. So I'm plugging in the x coordinate is to 0. So 0 plus 1 equals 1. So the slope is going to be 1. What I do is I line up my, you can use a ruler if you have one. I just use a flashcard. I'm going to create a line segment that has a slope of 1. I'm going to have to go up 1 over 1. I'm going to kind of angle my ruler that way and then just make a line segment like that. Now the line segment could kind of go maybe about halfway into each box or each square. Okay. And anytime I have an x coordinate of 0, well, 0 plus 1 is going to be 1, so all these slopes are going to be equal to just 1. So I'm going to angle the next one up, and that's going to have a line segment slope of 1, and the next one up is going to have a line segment of 1. So all these along this line have a slope of 1. Alright. Okay, so they all have a slope of 1. Now, if I move over here to x equal to 1, 1 for the x coordinate plus 1 gives me 2 for my derivative. So all these are going to have a slope of 2. So what I have to do now is angle my my flashcard such that it has a slope of up 2 over 1. So it's going to be a little bit steeper than the previous slope. So this has now a slope of 2. You can see in comparison it's a little bit steeper. Now move all along this line, and they all have a slope of 2. Alright, so by comparison you can see that these are a little bit steeper than that. Now moving over another unit to the right, over here the x coordinate is 2, but when I plug in 2 into my derivative, the value of it is 3. So now I need to make a line that has a slope of up 3 over 1. So I have to angle this, and now this is going to be even more steep, or even steeper. So all these are going to be a slope of 3. Right. Okay. And it's a little difficult to tell the difference between the slope of 2 and the slope of 3, but as you kind of draw the whole thing, you'll see how the overall shape of the solution curve looks like, or the slope field. All right. So let's go over here to the left side now. Let's go to the negative values. If I go over here to x equal to negative 1, well, if I plug in negative 1 into this, my derivative is going to equal 0. So it's going to have a 0 slope. So all these are going to be horizontal. So a 0 slope is a horizontal line. So all along where x is equal to negative 1, I'm going to have a 0 slope. So it's just going to be a horizontal line going this way. Okay. Now if I move another unit to the left, x equal to negative 2. Negative 2 plus 1 is negative 1. So now all these are going to have a slope of negative 1. So I have to be able to go down 1 over 1. So that's how you angle your ruler. Let me draw another line segment that way. So hopefully after drawing these a couple of times, you kind of get the overall pattern, or you get the hang of how these are done. Because basically what these are, they're just creating a pattern, and it's revealing to you what the solution to this derivative looks like. Alright. Now if I go one more to the left, that's going to be an x-coordinate of negative 3. Negative 3 plus 1 gives you negative 2. So now the slope is going to have to be negative 2. So it's going to be steeper in a negative direction. Alright, so it's going to look like this. Alright, so it's something like that. And I'm just going to continue this way. Okay. Alright, let's draw this one last one. Okay, so let's take a step back now and look at overall, like what the big picture of what we just did. Okay, we created a slope field, and this slope field represents the solution to this first derivative. The solution if I were to go back to the function. And we can kind of confirm this because if I take the integral of this, if I take the integral of my derivative, I'm going to end up back at the function. So if I take an integral of this, it's going to be x squared over 2. Power rule on 1 is just going to be x plus c. So x squared over 2 plus x plus c is well, graphically we should know this as a parabola, right? And you can see that the slope field is in fact a shape of a parabola, right? And the c-value determines the height of where you draw your parabola. So if you want to, like, let's say, have it go through the point 1 and 1, then you would solve it for the particular c-value, and that would ensure that your parabola goes through that point. Okay. If you wanted to go through, let's say, negative 2 and negative 3, then you would solve for the c-value, and it would go through that point. So what you have here is a solution to this first derivative. So what you have is the function based on the slope of the first derivative. So I have to kind of sink in and marinate for a bit. Alright, I did have you guys construct, or I did have you guys glue 2 additional graphs or grid paper on your guys' notes. I don't want to make this video too much longer, so what I'm going to have you guys do is just copy down the problem. In class tomorrow, what we'll do is we'll construct the slope fields to this. And I'll talk about some key points, maybe some things that'll make it a little bit easier, a little bit faster for you to construct them. So this is example 2. And example 3 is like this. So again, we'll create the slope field in class tomorrow based on these examples. And that's it.